Good afternoon. Hi, everyone. I'm Iria Heitel. I'm part of the AC Emerging Professionals London and Southeast Committee, and welcome to this AC Emerging Professionals webinar. Today, we're exploring the importance of incorporating the effects of climate change on the UK's policy framework. And we will also explore the importance of design sustainable construction and how early carbon assessment can contribute to climate change mitigation. Also, we will launch the whole life carbon roadmap. We're going to introduce the roadmap that will be launched at COP26 next month. Sorry. So today we have joining us Karl Desai of UK Green Building Council, Dr. John Orr from the University of Cambridge, and Ioana Price from AECOM. At the end, there will be some time for Q&A, so you can ask any questions via the chat. And also we are recording this session and we will share with you after the webinar. I will now like to introduce our first speaker, Karl Desai, Senior Advisor within the UK Green Building Council's Advancing Net Zero team, which is helping to lead the UK's transition to a net zero carbon built environment. Development of the UK Green Building's Net Zero Carbon Buildings, a framework definition which catalyzes industry-wide action in tackling whole life carbon. He also co-authored Building the Case for Net Zero, which helps provide the building sector with greater confidence on the design and cost changes required to deliver net zero buildings. I will now like to hand over to Karl Desai.
Thanks, Iria. I'll just pull up my slides. Thank you for the introduction. I guess I don't need to introduce myself again, so I'll just start my timer and get stuck into my slides. Thank you all for joining us for today's session. So yeah, I'll be talking about kind of big picture climate change and how that relates to buildings and your work as engineers. So just in terms of context setting, I think this slide is really quite impactful. It shows today's context, kind of we've all been very worried and taking rapid and worldwide action on addressing the effects of COVID-19. But similar crises lurk in the background, and the climate crisis is one of those. And one, we need similar level of kind of pace and scale of action to what happened with COVID, in fact, maybe even more so. So I think there's lots of similarities we can draw from what's happened in the last 18 months to what needs to happen in addressing the climate crisis. So exactly what needs to happen is kind of shown on this slide here. So the IPCC reports have told us time and time again that we need to achieve net zero emissions by mid-century. So this bottom purple line, and critically, we need to halve emissions by 2030. So within the next 7 or so years, we need to drastically reduce global greenhouse gas emissions. Currently, we're tracking on an upward trajectory, and we're looking to hit a warming scenario of greater than 4 degrees by the end of the century, which will spell about kind of disastrous effects of climate change. So relating this to our profession in the built environment, well, these are some commonly used stats. In fact, the stat that we like to use is that the built environment is responsible for about 40% of global greenhouse gas emissions. So there's a significant impact that the built environment has, and a key part of the solution also in delivering against that net zero target. Now, just in terms of setting that backdrop against and making it relevant to the building sector, what we're doing in the Advancing Net Zero team is taking these high-level aims. So taking kind of the findings from the IPCC reports, understanding what the UK government is doing, so setting a 68% reduction by 2030, which is good to see. Understanding how that relates to the property and construction sector, relating it to kind of carbon budgets. Understanding what role businesses have to play, and then again, how that relates to the component part of buildings. So our work spans some of those levels, importantly, the whole life carbon roadmap, which Iria mentioned and which I'm going to talk about, and then getting businesses to commit to net zero carbon buildings and also a net zero framework. So I'm going to talk about the roadmap and the framework in the next 5 or so minutes. So the Whole Life Carbon Roadmap, we brought together a range of industry experts. UKGBC represents the entire breadth of the construction and property value chain. And we intended to produce two key outputs. So the first is a science-based trajectory to understand exactly what it's going to take from the building sector to achieve the UK's net zero target. So essentially taking the Committee on Climate Change carbon budgets, relating that to the building sector, understanding how much we have left, and then apportioning that out across the different sectors. So for example, understanding how much residential sector has to remaining, non-residential, offices, industrial, etc., etc. Following on from that, we also know that there's going to be a steep level of reductions that's going to be required from the industry. So we've set out a report which identifies the key industry actions and government policies that will be needed to ensure that we're on track to delivering against those trajectories. So just to give you a bit of a sample of what that looks like, as you can see, the building sector has been reducing its overall greenhouse gas impact, but there's still some way to go. So bottom of the chart in green, you can see the operational energy usage of domestic and non-domestic buildings. Our housing stock is a lion's share of that, so lots to do on the residential sector and importantly retrofit. Looking at infrastructure, that's a small sliver, that's in grey. And then looking at capital carbon, which is everything to do with the embodied carbon related to the construction products and materials used in our sector. So this will set out exactly what needs to happen in terms of high-level targets and how that can be related to building-level performance targets. And then on the actual doing part, we will have a series of policy and stakeholder action plans. So this again is just a snapshot of what that will look like. We have central government recommendations across a 2025 and 2030 timeframe. And then we break that down even further to make it a bit more relevant to specific stakeholders. So for example, investors, developers, facilities managers, and contractors. There will be recommendations in there for kind of building services engineers and structural engineers also. So I encourage you to engage with that output when it's released. There will be a series of documents which form kind of the collateral around that. As Iria mentioned, that's due to be launched at the Bays stand in the blue zone at COP on the 11th of November. We'll also be running a virtual event in parallel to that, so you can log on to our website and find the details for that. And then we'll be following that up with an industry launch event happening in December. So pretty much a repeat of what's going to be released in November. So I've got 6 minutes on the clock. I was told we've got about 7 to 10 minutes. So I'm going to spend another 2 or 3 minutes on the net zero carbon buildings framework. So essentially that's the roadmap, which is kind of sector level trajectories and actions that need to take place. The framework definitions is something we produced a couple of years ago to try and instill action today on delivering net zero carbon buildings. Essentially, there was a lot of confusion in the industry around what net zero means and how that relates to buildings. So we produced this framework definition with the assistance of, again, about 50 industry experts. We pulled together a task group and we had about 13 industry bodies supporting it also. And the framework is centered around these three overarching principles. The point that I'd like to kind of focus on is the third one, about ensuring that we encourage action today so that we don't wait for all the pieces to fall together into the puzzle. We need to take action now in decarbonising and achieving net zero. We might not have all the answers right now, but we need to start on that journey. And when we talk about net zero carbon buildings, it's important to understand what whole life carbon means. And that's made up of two key components, embodied carbon and operational carbon. So everything related to embodied carbon is shown in blue on these two charts. And as you can see, that makes up a significant proportion of a building's whole life carbon impacts. Critically, everything in dark blue is what we term upfront carbon. So that's all the construction related emissions up until practical completion. So before that building is even occupied. That's a significant chunk of carbon which we are trying to mitigate and zero out with the whole life carbon, with the net zero carbon buildings framework definition. So essentially, if we lay out that whole life carbon kind of the scopes across the life cycle of a building, you can see here it's broken down into its component parts using the EN 15978 standard. What we've done with the net zero carbon buildings framework is actually produce two definitions. One which is related to all the construction related emissions, so for new buildings, and one related to the operational energy use of existing buildings. But we do understand that we need to move to a whole life carbon approach. However, that wasn't considered feasible or practical today. So we feel like these are the two priority scopes of carbon that we need to tackle today. Just quickly breaking down those two definitions, we've also set out a carbon reduction hierarchy. So I think the following presenters are going to go into a bit more detail on this, but essentially for new buildings, we need to make sure we're reducing the embodied carbon to the greatest extent possible. We're designing for low energy usage, on-site renewables where possible, and offsetting that carbon in full to achieve a net zero carbon balance. For buildings in operation, embodied carbon is less important. So the priority measure there is to reduce operational energy use, move to 100% renewable energy supply, offset any carbon if needed on a 12-month basis, and then publicly disclose against that. In summary, this is what we need to do to achieve net zero carbon buildings. We need to reduce everything that's on the left-hand side of the scale, and we need to increase everything that's on the right-hand side of the scale, obviously with a decreasing reliance on offsets. And I will leave it there. Back to you, Iria.
Thank you very much for that, Karl. So I will now like to introduce Ioana Price, our next speaker, and she's senior structural engineer at AECOM and finalist for the 2021 IStructi John Orr of the Year Award. She will introduce Scope X, a process developed by AECOM to reduce carbon through design to help end the climate emergency and enable early project stage carbon and cost optioneering. She considers early holistic carbon assessment essential to all new projects, and she is currently developing AECOM's own embodied carbon tool aimed at enabling early project stage carbon and cost optioneering to tackle the climate emergency in line with the UNE's Sustainable Development Goals. I will now like to hand over to Ioana.
Thank you, Iria. Let me share my screen now. Hope it works. All right. Can you say if I hope you can see the screen?
Yeah.
Okay, perfect. Right. Well, thank you for the introduction. I think I'll dive in straight head down. Just before actually I dive into the detail, I just want to follow on from what Karl said in his presentation, and that is really, I think we do need to understand a little bit better of where the carbon emissions from our buildings actually sort of sit, where the bigger portions, the smaller portions, and what we need to address. Obviously, as a structural engineer, I'm quite interested in the embodied carbon emissions because this is sort of within my realm of sort of what I can do about it. So what we can actually see on this graph, which sort of is a graph which compares the embodied versus operational carbon emissions throughout the building life. So what we can see is that actually nearly half of the carbon emissions are emitted at the very start. So that's pretty much sort of before the building even opens. So this is all due to the actual making of the materials, is due to the constructing of the buildings themselves. And this is really sort of the big item or the elephant in the room, which is not currently being regulated and we need to rapidly address, as Karl mentioned also. So it's a really big issue. And so there's a fair few things we can do about this to actually start addressing this as quickly as possible. So within AECOM, we've developed a 6-step approach to reducing the carbon implicit in our designs, starting with refurbishments. So because the best way to reduce the carbon emissions of new construction is to just try and not build new in the first place and encourage saving the buildings that currently exist in the world around us. Step 2 is reusing. So we're sort of looking at encouraging reuse as much of the existing material on site as possible. Step 3 then comes in. This is a scenario where we have to build new, when there's no other option, and this is where we're looking at estimating and calculating the embodied carbon emissions of our schemes at day 0. This is actually the significant step in the uniqueness of AECOM's approach to quantifying embodied carbon, and this is where our tool comes into place, which I'm going to sort of talk about in just a moment in a bit more detail. Our step 4 is specify. So we're looking at specifying and promoting the use of low carbon materials and low carbon technologies, but also quite importantly, engaging with the supply chain early to make sure that those materials are actually going to be available when the building gets to go to site to get constructed. Step 5 is detail. So we're looking at designing connections and element parts and components to enable them to get disassembled and reused at the end of the building life. And finally, last but not least, is we're looking at optimizing our designs in an effort to reduce the material waste. So engineers really can make actually quite a big difference, and we can really help reduce the carbon emissions in our designs, but only if we're involved early in the project stages. So if we have a look at the graph to the left, we can see how the more the building develops, the more the design develops, the more difficult it actually gets to influence the carbon emissions. Thinking of the project stages of how we work at the moment, this is currently roughly where engineers get involved. So basically, by the time we come in and have a sit on the table, most of the key decisions have already been made. So someone's decided whether they're going to build, they've decided what they're going to build, how big that building is going to be. Often the room layouts are decided as well. So actually us as sort of structural engineers and mechanical engineers, it's very difficult to make any impact on the carbon footprint, because we're just trying to design our structures and services to fit within predefined constraints. So in order for us to actually make a real difference, this is where we need to get involved at the very, very early project stages, strategic briefing stages, where people are sort of trying to decide whether the building that's on site can actually be saved, or if you need to build new, what can you build to make sure that the carbon footprint is as low as possible. And this is actually where our embodied carbon tool comes into play. So within AECOM, we've developed our own in-house tool, which is called EcoZero. And it's essentially, it's an embodied carbon and cost optioneering tool. The idea is for this tool to be used exactly at those early project stages. So we're talking REBA stages 0 and 1. And the idea is that the tool can sort of help define the building shape, the building form, can help define the size of the building and the key materials with the carbon at heart, basically. So what we do is we've collaborated across multiple disciplines, because we appreciate that we really need to sort of look at holistic carbon assessments. We can't just focus purely on the structure. Obviously, a big element is the structure. But in addition to that, we have geotechnics, we have input from our own facades, architecture, and cost management team in order to offer this holistic view. The tool is currently sort of offering at a glance carbon comparison of 11 different structural typologies. So we're looking at multiple concrete options, multiple steel options, timber, and some hybrid options as well. And really the idea is that you can sort of play with different geometries, different column grids, different materials, so that you can tailor your scheme for the most optimum carbon solution. And next, I've got a little video to show how the tool works in practice. Brilliant that it works. So all you need to do is basically to get it going is you need to just draw an outline of a building, and then immediately a building pops up in front of you. The idea, as I said, is to sort of use this as a decision maker tool to choose the best material shape, to the best building shape. What the tool does is essentially, when you change some of the key metrics, you can play around between different materials. You can change the spacing between the columns, for example. And whenever you change something, the data that you can see in front of you actually gets updated live in front of you, as it draws information from our own extensive database set. So, for example, when you change the column grids, the sizes and the slab thickness of the building that we see in front now actually change live in front of you, and the associated material tonnage and carbon also change. You could sort of play around with different, you can increase, add stories, subtract stories, and see what effect that has on the overall carbon and where that sits in terms of our benchmarks. As I said, we've developed as a multidisciplinary tool as well. We are looking at foundations. So for each of the 11 structural typologies, we generate a different foundation solution, which is tailored to be designed specifically for the site that we're looking at. And all the input it needs is just a sort of simple ground model, which you could get out from any BGS borehole logs, which sort of exist for nearly any part of the country. So it's not too difficult to do. So that's kind of it on the tool. I think this is probably the end of the video. So I'm just going to move on to the next slide, conscious of time. So really, from using our tool, we've already started to establish some key trends and some simple steps that we can take to achieve low carbon construction. And I've extracted some of the highlights here, but actually the list is much longer. I just don't have enough time to tell you every single bit. But so what some of the highlights we've got is that increasing column spacing actually results in an exponential rise in embodied carbon. So we're trying to promote using regular grids and closer column spacings. Another interesting study we did a couple of months ago was on structure versus facade carbon. So this is essentially a study we did to try and highlight the importance of doing holistic assessments. Because sometimes if you do a sort of an embodied carbon assessment, when you're purely looking at the structure, almost always the timber option is going to come out as the winner. But something that people sometimes don't really appreciate is that timber does come, the cost of using timber is mostly that it comes at the deeper sections, which ends up increasing the depth of the structural zone. And so if you look at maybe a longer spanning solution and in a multi-story building, the little bit extra that you get at every floor when you compare it against like a concrete solution, for example, could amount to quite a lot. And so then if you compare the different overall building heights between, let's say, a concrete solution and a timber solution, it could be sort of a difference of a few meters, which is not insignificant at all. And what that means is then you have quite a lot of additional material for facades or internal partitions, or the kind of non-structural elements, which also carry quite a lot of carbon with them. And really to sort of be able to actually tell and advise which option is really the most carbon efficient, you can't do that without looking at every component and quantifying the carbon in a holistic way. And sort of last but not least, of a kind of play of words here, but we're also looking at doing basement carbon impact assessments, where we could sort of look at what is the difference, for example, if your building has a single story basement, and what is the carbon difference if you take out that basement and instead add another story over your building. And actually, more often than not, the basements are quite carbon intensive structures, and we are trying to advise our clients on not building basements, and really using that information. It could really help reinforce those statements, and hopefully can help drive the key decision-making process. So that's it from me. Thank you for listening. Hope I managed to fit in within the time, and just stop sharing now.
Wonderful. Thank you very much,
Thank
Ioana.
you.
Thank you. We will now do our first poll. So you could just share the poll, please. Okay. So you should be now seeing the questions and your screens. We will just give it a couple of minutes. Okay. So the question is, who in your opinion is responsible for driving the net zero agenda? The government, the private sector, both, neither. And 78% answered both. No one answered neither. So we will have some responsibility. And 11% said the government, and the other 11% said the private sector. Really interesting. Okay, so I think I'd like to introduce, I'm going to introduce our next speaker, Dr. John Orr, University Lecturer in Concrete Structures in Engineering and Physical Science Research Council Early Career Fellow in the Department of Engineering at the University of Cambridge. His teaching and research are closely linked to sustainable construction and improving construction sector productivity. He works in concrete structures, creating new methods for analysis, optimization, and automation in construction. He is specialized in design optimization and lightweighting of existing and future infrastructure by learning from real performance, and provides expert consultancy to leading engineering and construction firms. I will now like to hand over to Dr. John Orr.
Thanks, Iria. Hopefully you can see the screen. Good afternoon, everyone. Excuse me, I've got a bit of a tickly cough at the moment. I'll speak very briefly about some of our work in Design for Real Performance, is the title here. I just wanted to show one graph just to recap essentially what Karl said, just to highlight why this is important. This is obviously CO2 emissions globally from 1970 to 2020. And that's those two lines, the red and the blue. These are the projections from the IPCC that will give us a chance of getting to 1.5 degrees warming. So we've all been educated and worked on that upslope. So whilst there are very good examples of low carbon design, generally speaking, CO2 emissions have been going up. And on that graph, for me, it's like a bit of a ski jump leaping off after 2010. And it's a pretty big challenge is really what this graph is telling us. And what we're going to look at in a few moments is changing completely the way that we design things. I think the previous practices that we've had have demonstrably not been good for the climate. So although that looks like a very scary slide, we need to reduce our emissions every year between now and 2050, I think it's a really big opportunity for us to do things in a much better way. So it's an exciting time rather than being a really terrifying time. So our motivation then, in response to that challenge, is really to think differently about how we use materials in construction. So do we know how much material we need? Does it perform as we expected it to? And as we start to change our practices, do unexpected things happen? Okay, so and then how do we deal with that? So in our hierarchy of things to do as we move towards net zero, using less stuff is the first thing to do. So just use less. You can then deal with your specifications, and very, very much the last thing is you can offset and offset appropriately. Offsetting is not the answer. Using less stuff is the answer. So every sector of our economy has to change, of course. This is not just construction, it's everybody. So we all have a responsibility. And really what we're going to talk about here is the importance of measuring what's going on. So if we want to use less material, we really need to know how our structures are performing. So from a structural engineering perspective, we want to know things about serviceability, performance, ultimate limit state performance. And from a carbon perspective, we really want to know what's in our building. even something as simple as that is still relatively unknown. So if we first look at structural design behavior, this is just a picture of a beam that was tested at the University of Toronto back in 2015. So it's a 19-meter span beam, it's 4 meters deep. And what they did, which was very important, is they sent all these details around to anybody in the world who wanted to see it. Before they ran the test, they asked for predictions of how this beam would fail. Okay, so it's a simply supported beam. This is very basic structure. What point load would cause failure? 50-50 responses from academia and industry, so our best minds around the world. The predictions range from 250 kilonewtons to nearly 4 meganewtons. Okay, so first of all, that tells us something about the uncertainty within design. It actually failed at 685 kilonewtons, and only a few people were within plus or minus 10%. So the reason I'm putting this up here is a simply supported beam of this size is unusual in a testing environment. We don't often test beams this big, but it's not unusual in real life. And so if we can't actually accurately assess or predict the capacity of a structure of this scale, then how on earth can we be confident about how things are working when we build them? So one response might be, well, let's just be very conservative and use, excuse me, let's be very conservative and use material as our risk mitigation. Unfortunately, that's not compatible with climate change. We can't do that. So we need to know how buildings work, how structures work, and then improve our design practice as a response to that. So let's be honest about what we don't know and stop pretending that we know everything. So that's the structural side. And then on the carbon side, we still have relatively little data about how much embodied carbon is in buildings. Excuse me, this is just one example from a US database of commercial offices. So we've got 500 commercial structures here, and you can see the range is quite big. We've got a sort of median of 400, but all the way up to 2,700 kilos per square meter. So when we come to look at embodied carbon, we really need to know, what does good look like? What is the best practice in this field? And that really requires us all, either individually or as companies, to start sharing our information. So sharing your design, sharing your carbon assessments, making sure we've measured in the same way. This is a kind of a key point with embodied carbon. You can measure it in all sorts of different ways, and you can get all sorts of different numbers. And ultimately, for me, it doesn't really matter which method we choose, so long as we all choose the same one and then compare across companies, across sectors. And it's only through doing that we're going to be able to learn at the speed that we need to learn to deal with the climate emergency. And so what this really, for me, kind of comes down to is, just a quote from a nice poem, is really to embrace the idea about getting things wrong. And that's something that's really foreign to many people. Getting things wrong is viewed as being a bad thing. But as you make mistakes, as you have an error, you learn something. And as you make more mistakes, you learn more and more. And so this is the quote here. So we need to get onto that road of understanding how things really work, where the carbon really is, and collectively move towards a lower carbon design. So what that means is this virtuous circle of designing, analyzing, building, measuring, and improving. The reality of most design is you send your drawings off, the building's constructed, and you never go back and check, is my finite element model actually correct? Because first of all, you probably won't be paid for it, but also you don't perhaps want to know if your model was correct. But if we can close that loop, close that circle, we have a better chance of improving our design practice. And then in the center of our circle there, we've got those three kind of key things about zero carbon, resilience for infrastructure and buildings, and being resource efficient. So this is quite a significant change. But if you think back to that ski slope jump, this is the kind of change that we need. So one of the key things as an immediate step as you start to use less material is that you might start worrying about serviceability. So there is lots of work, interesting work going on in this field. And I just thought I'd put up the B Simulators project, which is Bath and Exeter universities. So what often happens is we start to change the stiffness of structures and we don't know how they interact with the humans inside them. So it's really important as we start to go on that road towards lower carbon that we ensure we are addressing all the potential impacts of changing the way we design structures. So what this does here is it allows us to assess the human structure interaction of a lightweight building, a slender building, and ensuring that they are still fit for purpose. So it's a much more sophisticated way of design. And then my final slide here is about this idea of reporting. We need to share data, we need to share information with each other. On the left-hand side, you've got the RICS carbon database, which has been around for quite a long time now. And if anybody is doing carbon assessments, I'd encourage you to submit your information to that database. It can be anonymous. You don't have to provide your company name and so on. So that's one thing. On the right-hand side, this is really for the structural design. And you may recognize this from EcoZero. Things like partial factors and psi factors in design, they really come from a long experience of building tradition. So it's not really based on data in the way you might expect. So that's just in case you didn't know, but in point B there, you see that the whole of the Eurocodes allow you to do statistical observations, field observations, probability. So what I'm essentially saying here is we have all the tools we need within existing design codes to actually do a lot with reducing material and making our structures perform better. So that's me. Thank you, Iria.
Thank you very much. Thank you for your presentations. Now we are doing another poll. Yeah, you're gonna see shortly in your screen. So do you feel personally responsible for the carbon footprint of your projects? And yes, 63%, no, 38%. Interesting. We have another one coming. Do you think you can contribute to decarbonizing the construction industry? So yes, 89%, and no, 11%. So I think now we'll move on to the Q&A session. So we have a couple of questions in the chat. I'll start with a question. What database do you use to gather the carbon information, such as the environmental product declarations, EPD, for the AECOM tool? Ioana, would you like to answer this question?
Yeah, I see this one is for me. Yeah, I'm happy to answer. It's a great question, actually, and I think it sort of links in with something that John mentioned in his presentation as well. But I'll start by just answering the question in the simple terms. So we, generally speaking, we've based our carbon database on ICE and some EPDs where they are available. The reason for this is, so the institutional structural engineers over the past maybe 18 months have actually done quite a lot of work on trying to sort of set the scene and lead the way and help other engineers sort of address the climate emergency and start measuring the carbon within the structure in the same way. So the ISTRUCT have put together some guidance documents on how to calculate embodied carbon. They've also done their own tool, which is actually really good as well for sort of helping smaller practices measure the carbon of their designs. And so to be in keeping with the same approach, we have used their database, which is primarily based on IC. But just to add to this, I think there's actually quite a lot of disparity between the different carbon database sets. There's a lot of different tools going on. The one-click lifecycle assessment. There's E-tool. There's, I think, BRE. There's quite a lot, like you mentioned, RICS. There's quite a lot of different sort of database sets going on around, which actually often have pretty significant differences for the same materials. So at the moment, there is this thing called the Built Environment Carbon Database. So a number of institutions, including the ICE, IEEE, BRE, Carbon Trust as well, sort of have grouped themselves together to try and to develop this sort of common database, which would be applicable and built specifically for the built environment, so that everyone can use the same data, which could hopefully help us get to the right answers. Kind of again links to John, to your points at the end of sort of having a building that has like a carbon of 2,500 kilograms per square meter, and then the other one was somewhere in the low hundreds. So hopefully this will help.
Yeah, thank you very much. So I had a question coming asking, how can we ensure efficient measurements and transparency in the operation stage? Who would like to answer this question?
I'm happy to have a go at it. So presuming that's about operational energy usage and use. So what we advocate for with the framework definition and in all our work is in-use energy measurement and reporting. We feel that modeling and energy modeling is fine to an extent, but as soon as that building switches into operation, we need to use in-use reporting mechanisms. So the likes of Neighbours UK is quite encouraging to see that come onto the market, because that's actually annual reporting, and it has a star rating system as well, so that can encourage good performance. So yeah, I think that might tackle the operational energy side of things. I think with embodied carbon in use, that's still quite a nascent field. Typically, it's not really being measured or reported on. Some of the leading developers might calculate their kind of repair and refurbishment works across an entire portfolio, but it doesn't give you that granularity on a building by building level. So hopefully that's answered the question.
Yes, wonderful. I wonder also, well, I have another question first. Regarding advancing net zero, how are we planning to tighten the requirements over time?
Yeah, I can take that one. So what we are doing is we've termed it a framework definition, because that's exactly what it is. It's a framework which we'll add layers onto over time. Last year, we released energy performance targets for offices. So to say that if you want to claim to be a net zero carbon office building, you need to hit to this level of energy performance. We're hoping to enlarge that to cover other building types as well. So for retail, industrial, residential, etc. There's already some provided by REBA and LETI. And then moving from operational energy to also embodied carbon performance targets. So that again, REBA and LETI have taken a stab at determining what they might be, but actually taking the outputs from the whole life carbon roadmap to develop science-based performance targets. So to say, actually, this is what we must hit. And there's not much variance in that. So yeah, I think the performance targets is one piece, adding additional assurance and kind of robustness around the renewable energy procurement side of things and offsetting as well, because those are still emerging fields. So we've provided a bit more guidance on that, and we hope to deepen that over the next few years. But welcome any suggestions as to what others think we might be able to do to help advance net zero.
Thank you very much. I had a question in the chat.
Sorry, can I just say one more thing on just on the back of what Karl just said? It's I guess like we've done quite a lot as a private sector. I feel like, and actually UKGBC has really sort of led the way on kind of helping the industry sort of map out the routes that we need to follow and the steps we need to take to get to net zero. And I feel like really the missing piece of the puzzle now is the government role in all this, because ultimately we are developing like as I sort of showed you as well within AECOM. We've developed a lot of tools. We've put a lot of investment into enabling low carbon design. But at the end of the day, if the client currently is not interested, there's not much we can do. A lot of the time, the incentive is left to the clients. And while a lot of clients, specifically the bigger clients and government organizations, might be interested for their own sake to kind of go with a more low carbon development, ultimately we do need some sort of actual regulation in place, hopefully to come soon, maybe inspired with COP26 coming up. Can only hope.
Yeah, I agree.
Just very briefly, just to add to that, people may be aware of the proposal for Part Z to the building regulations. So that's an interesting project going on, led by a whole bunch of people, including EPSRC, to add this Part Z, which would cover some of those things to our building regulations. So if you haven't heard of it, just Google Part Z building regs. There's a whole website.
Thank you very much for that. So we have another question. Does anyone think penalties for not reducing carbon could be effective? Linking to the previous question.
I can give my thoughts if you like. Penalties is always a difficult one. The analogy I can make is fines for your children not going to school. And some parents pay the fine in order to take their children on holiday. So if you can afford the penalty, you can play the system. So it might not give us the results you need. It's also the question of how on earth would you measure what the penalty should be? So there's that kind of side of it. Having said that, taxes generally, tax on construction has been effective in the past and has helped shape what our cities look like. Two good examples are Amsterdam and Paris. The famous architecture of Amsterdam and Paris has come from taxes that they had. So there might be a role for that, but I would just be cautious of immediately going to it being a penalty. I think one of the key things we need to do with construction is not tell everybody off, because we've been doing that for decades. There's been lots of construction reports saying how bad we are at productivity and so on, but really to focus on what we're doing well and enhance that. So I avoid penalties to begin with myself.
Yeah, thank you. Have another question coming. What measures can be taken to ensure a coordinated action between holders involved? Maybe, John, would you like to answer this question?
I actually didn't hear half of it, so you'll have to repeat it, sorry.
What measures can be taken to ensure a coordinated action between key stakeholders? Yeah,
difficult question. Well, this is, again, one of the problems with our current construction sector is it's extremely fragmented. So if we compare construction to aerospace, in aerospace, there are a few big players. It's not the same in construction. So bringing everybody together is really, really difficult. And I'm afraid I don't have a magic answer to that question. I'm not sure if Ioana or Karl have a solution, but it's something we need to do, but actually doing it is very hard.
I think for me, like, as you say, like we're definitely working in silos at the moment, which is one of the big issues. But in my mind, one of the ways that we can tackle this is to actually bring in engineers and environmental professionals to those early stage sort of strategic meetings, so that they could sort of consider the design and the development, sort of the direction of the design from that kind of holistic view. Because the reality is that there isn't just one person that knows everything. You just have to bring in the key professionals that can actually help shape the right way.
Yeah, the only thing I'd add to that, I totally agree. Early engagement is critical. I think also widening out the responsibility to all stakeholders. So rather than it being the designer having to kind of ask the client to get on board with a low carbon design, it should be the client also wanting to demand that from their design team, and having that awareness and advocacy across the entire range of stakeholders involved in that project. I think that would be also helpful to support low carbon designs.
Yeah, I think this is really interesting because we usually don't really have time to reflect on what went wrong. And I think maybe establishing like a structure where everyone will need to answer certain questions and be able to provide quantitative data as we are measuring the effects of design, if it was a good design or not, or what can we learn from it, is, I think, is key in determining what can we improve in the future. So that's been really interesting to learn more about performance-based design and how that could be applied, and also maybe how we can really develop more of a transparency on current practice, and incentivizing as well some sort of awards or tax relief or anything that could make people think better, just not because they have to, but because they should. So no, that's been really, really interesting. I don't know if we have any other questions.
I had maybe just something to add and ask. So I really liked that idea, sort of that you presented, John, for comparing what has been built versus what was designed. And I think that would be quite interesting from a carbon perspective as well, because often, like, we think we may have sort of specified really low carbon concrete, but it didn't get built or something like that. So that's quite an interesting idea. And then the other thing you mentioned at the end with the design codes and the sort of different factors that we use at the moment. Do you think that maybe it's like about time that the design codes we use need to be updated? I think I know the answer to that.
I'll answer the second one first, and I'll be careful what I say. It took a very long time for the Eurocodes to actually be introduced. I forget how long it was, but let's say it was 20 years of committee meetings to go from British standards to Eurocodes. I personally think that we have within Eurocode 0 a lot of scope to do a lot of really good stuff. I know some of the people who chair those committees, and the Eurocodes are very flexible. So personally, my own opinion, just my opinion, is that we can do a lot with what we already have. We don't need to worry about changing codes. That kind of just kicks the problem down the road. Just say, oh, we'll wait for the next version of the Eurocodes, and then that takes 20 years and it's too late. We need stuff now. So that, yeah, that's my political answer.
Thank you.
Thank you. I think we are out of time. Thank you all for your presentations, and many thanks for listening. We hope you found this interesting. Thank you especially to our panelists, Karl Desai, Dr. John Orr, and Ioana Price. Just a reminder that we recorded this webinar and we'll send you a link in the next few days along with a copy of the slides. Have a good one, everyone.
Thank you.